confidence intervals and p-values, regulator-ready ML claims. Welcome. Today we'll make your model claims clear, credible, and regulator-ready. Regulators expect measurable claims, not promising, but numbers they can verify. Use transparent, testable phrasing like reduced false positives by 12% rather than much better. Always separate model hype from evidence. Say what the model aims to do, then show what it actually did under a defined test. This protects you, guides stakeholders, and builds trust. By the end, you'll know how to present results so a reviewer can reproduce them, and your leadership can act on them confidently. A confidence interval, CI, gives your estimate plus its uncertainty band. Instead of one number, you show a plausible range for the true value. Example: AROC 0.87, 95% CI, 0.84 to 0.90 means that, across repeated samples, intervals built this way would contain the true AUROC 95% of the time. The center tells you the estimate. The width tells you precision. Narrower CIs need more data or less variability. When presenting results, pair the point estimate with its CI so others see both performance and uncertainty, crucial for risk-aware decisions. A p-value is the probability of seeing data this extreme or more if there were no real effect. It answers, how surprising is this under no effect? Not, how big is the effect? Thresholds should be pre-specified, e.g., 0.05, to avoid cherry-picking. Remember, small p does not equal big impact. You can have a tiny p-value for a tiny, unimportant difference with huge data. Always report the effect size and its confidence interval alongside the p-value so stakeholders understand both statistical significance and practical importance. Move beyond a significant to so what. Report absolute and relative gains. Error dropped from 10% to 8%, absolute 2 points, relative 20%. Then translate to decisions or costs. Saves 200 reviews per week, or cuts claim leakage by $45,000 per month. This grounds the result in business impact. Finally, avoid overclaiming small effects. A 1% lift might be huge in fraud detection, but trivial in marketing response. Always pair the effect with context, baseline rates, operational constraints, and risk tolerance. Write a statistical analysis plan, SAP, before looking at outcomes. Define hypotheses, metrics, models, and how you'll handle outliers. If you run multiple tests, adjust error rates, e.g., Bonferroni, Holm, or false discovery rate, so you don't celebrate noise. Lock metrics, cohorts, and time windows in advance to prevent scope creep and p-hacking. This discipline keeps your results credible, reproducible, and defensible, especially when auditors ask, what decisions were set before you saw the data? To show real performance, use proper validation. Hold out a test set the model never sees, or better, use external validation from a different site or time period. Avoid leakage and peaking. No target variables and features. No tuning on the test set. No early stopping decisions based on test metrics. Finally, check subgroups for fairness. Compare performance by age, region, device, or other relevant segments. Document gaps and mitigation steps so your claims hold across the people who will actually be affected. Strong reports state assumptions and limits clearly, labeling quality, feature availability, and deployment conditions, flag data shift and generalizability risks. Models trained on last year's behavior may drift when incentives or user mix change. Note sample size and missing data issues. Small samples widen CIs. Missingness can bias estimates if not handled properly. Being explicit about caveats doesn't weaken your case. It shows integrity and helps stakeholders plan monitoring, retraining, and guardrails. Make claims specific and verifiable. Always include CI and p-value with the effect, and name dataset, period, and cohort. Example: on the 2023 Q4 claims dataset, N equals 12,480 adults 18 to 64, the new triage model improved recall by 7.2 percentage points versus baseline, from 71.4% to 78.6%. 95% CI 5.1-9.3, p less than 0.001, while precision held steady. Delta plus 0.6-1. This phrasing ties the result to a population, time frame, and uncertainty, exactly what reviewers need to trust and reproduce your findings.